Hey, Probstats kids, this is Dr. Callahan with week 14, Monday. I hope you guys had a great weekend. Go ahead and pause the video and answer the following 3 questions. All right, so let's go ahead and get started with today's stuff. Last time when I saw you guys, I had you guys go ahead and calculate the z-scores according to the worksheet that you guys had. And I just want to go over a few of the questions. The worksheet looked like this right here. And so let's just go ahead and focus on one of the questions here. All right, so let's take a look at this one here. Let's just go ahead and pick one and let's do this one. Okay, so if the x value is 14 and it's given to you that the mean is 10 and the standard deviation is 2, you're supposed to find the z-score and then color it. So what this means is that your z-score formula is always going to be x minus the mean over the standard deviation. So your mean here in this case is 10. Your standard deviation is going to be 2. So then we're just going to do 14 minus 10 divided by 2, which is 4 divided by 2, which is 2 for your z-score. Now, if you take a look at this right here, what does that 2 mean necessarily for your z-score? It means that I'm going to go ahead and look at the z-table to determine what percentage that is going to be in. Okay, so what that means is that here is your mean at 10. So right here in the center, that is 10. Now your value is 14. So then at 1 standard deviation, that's going to be 10 plus 2, which is 12. So that's not quite enough. Then here at 2 standard deviation, that means it's 12 plus 2, which is 14. So your 14 is going to be right here. Okay, and let's go ahead and take a look to see what percentage is going to be. If you're asking for the area right here in yellow, then all you have to do is just take a look at the z-score table. So you want 2. So let's take a look over at 2, 0, 0. So your percentage is 97.72. So then from here to here, 97.72% is that yellow area. Now, on the other hand, if you want to find just the right side of this, which is this piece right here, that blue section, then what you will have to do is you would just take 100 minus a 97.72, which will give you a 2.28%. And that's going to represent the blue area right there, okay? So that's what you did last time. Another question that we went over is if I specifically gave you the curve and you were supposed to estimate the z-score and then look it up. So here, if you look at it, this is the mean, okay? This is probably at 1 standard deviation. And so if I were to go ahead and estimate it and look at this percentage, I would say that this is probably at, actually that's not 1 here, sorry. This is going to be minus 1 standard deviation. This is going to be minus 2 standard deviation. And then remember, if it's going to be just this piece right here, it's 34%. And then after that 34%, it is 13.5% for the next side. So this looks like it's a little bit more than 34. So I would say maybe from here to here, it looks like maybe it is at 40%, just an estimate. So then with that 40%, don't forget the 34 here. And remember, oops. If you take a look at the remaining half of this person right here, this is going to be 50%. So I would just say if I'm estimating this entire gray shaded area, it's 40 plus 50, which is about 90% is my estimate. All right, so then today, this is our breakdown. I have a video for you guys to watch first, then I have a Quizlet right here, and then I have a worksheet for you guys to work on with the quizzes. So let's go ahead and get started with this. So with that said, let's go ahead and start with the video. All right, you guys. So let's go ahead and move on to the next part. Um, so then after looking at this piece here, let's go ahead and take a look at some of the questions I would like you guys to practice with. So take a look at this worksheet here. Okay, you don't have to have it printed out. You can just go ahead and show the work on a separate piece of paper. So let's take a look at the first question. All right, it says an adult female Dalmatian has a mean weight of 50 pounds. So the mean weight of adult dog, that's a Dalmatian, is 50 pounds, and a standard deviation of 3.3 pounds. Assume the weight are normally distributed. It says find the z-score of an adult female Dalmatian who weighs 60 pounds. Okay, so then we're kind of working a little bit backwards. Z-score equals x minus your mean over the standard deviation. Okay, and so looking at this here, let's go ahead and plug in the necessary numbers. So the z-score here, it's given to me that it is what we're trying to find, and here x is going to be 60. So then we're going to do z is equal to 60 minus 50 over 3.3. So then looking at this with your calculator, because you're going to need it, 10 divided by 3.3 is going to give you a 3.030. And that is your z-score. Now, if I were to go ahead and take a look at this on a z-table, if this mean is at 50 and I want 60, I know it's going to be kind of all the way over here towards the end, because at 1 standard deviation, it is going to be 50 plus 3.3, which is 53.3. And then at 2 standard deviation, it's 53.3 plus 3.3, which is going to be a 56.6. So it's going to be at 60. It's actually going to be at the 4th standard deviation, which is pretty far over to the right side. But if I were to go ahead and look at the table, so let's take a look at that. A 3.3 is going to give you 99.95%. So that means if I were to go ahead and find the shading of the dog that weighs 60 pounds, it's going to be all the way over here, which is going to be from here, left side, all the way to the right side. That's going to represent 99.97%. Okay, so that is one big dog. Now go ahead and do the same thing for B. All right, so C says find the weight of the adult female Dalmatian whose weight is 1.75 above the mean weight. Okay, so in this case, you have a z-score that is given to you right here that we found, 3.030 equals, so it says find the weight of the Dalmatian, so here is x, minus the mean, which is 50, over the standard deviation, which is 1.75. So with this one, notice that it's a little bit different than before, because before you're finding the z and everything here is just already plugged in. This is a little bit opposite because you're trying to find x. So you would have to do algebra a little bit more for this question. So first thing you want to do is you want to get rid of the 1.75, which is the bottom of the fraction. So what I would suggest doing is step 1, go ahead and multiply by 1.75 on everything on both sides. That is going to give you a 5.303 equals x minus 50. Second step, you want to get rid of the negative 50, so opposite of a minus is a plus. So we're going to add 50 on both sides. So the right side cancels. X, which is a pound of this dog, is going to be 55.33 pounds. And that is your answer. So go ahead and pause the video and do D as well. All right, let's take a look at number 2. Number 2 says the IQ score have a mean of 100, so 100 is the mean, and a standard deviation of 16. Albert Einstein reportedly had an IQ of 160, which is very, very high. So what is the difference between Einstein's IQ and the mean IQ? Well, the difference just means minus. So Einstein's IQ is 160. The mean of a typical person is 100. So the difference is 60 points. Okay. Now, obviously, Einstein's IQ is above the standard deviation of everyone else's, but how many standard deviation is that? So let's go ahead and take a look at this. Okay, so how many standard deviation is that? Well, let's go ahead and look at the bell curve here. So draw yourself a bell curve. Now, you know that the mean right here in the center is going to have an IQ of 100. Now, we want to figure out how far to go in order to reach to 160, which is Einstein's IQ. So then at one standard deviation, it is 100 plus a standard deviation 16, so that's 116. Okay, and that's just one standard deviation. So that's not quite where Einstein is. He's actually higher than that. At 2 standard deviation, it is going to be 116 plus 16 again, which is going to give you a 132. Einstein's still higher than that. So let's keep going. At 3 standard deviation, it is 132 plus 16. So that is going to give you an 8 for 148. So he's still higher than that. So then at 4 standard deviations, it is going to be 148 plus 16. So that's going to give you a 4, 6, so that's 164 IQ. Einstein is 160. So between 148 and 164, Einstein is going to be right there, which is at 160. So he is at plus 3.5 standard deviation above the general average, or above everybody else's mean. All right, so then convert Einstein's IQ to a z-score. So then z is equal to x minus the mean over the standard deviation. Well, so then z is equal to x. X is going to be 160 minus the mean 100 over 3.5. So that's going to be a 60 divided by 3.5. Which is going to give you a 17.14. And quite frankly, that is a z-score, but I don't even think you'll be able to find that on the z-table, because if you look at the z-table right here, the highest it goes is a 3.4. So 17 is all the way down here. And so if you look at the percentage, it is at 99.98%, and that's at 3.4 standard deviations, or z-squared 3.4. So what does that tell you? That tells you that Einstein is very, very smart, and it's so smart that, he's smarter than probably 99.98%, or actually even greater than that, of the general public. Okay, you guys, so then I would like you to go ahead and continue working on this. Go ahead and take a look at question number 3 and question number 4. All right, so for number 3, I'll actually go over this one with you guys. It says the women's height have a mean of 63.6 and a standard deviation of 2.5 Find the z-score that corresponds with a woman's height that is 70. So what you're going to do here is I'm going to put z-score is equal to x, which is 70, minus the mean divided by the standard deviation of 2.5. So then if I take a look at this, 70 minus 63.6 divided by 2.5 is going to give me a z-score of 2.56. And if you want to take a look at that on a chart, 2.96 is going to give you a percentage of 99.85. So 99.85% is what you're looking at. If somebody is 70 inches versus the mean of 63.6 inches. So if you're 70 inches, that means you're taller than 99.85% of the general population. For B, find the woman's height whose height is 1.5 standard deviation below the mean. So if the mean is right here and the mean is going to be at 63.6 inches, you want to look at 1.5 standard deviation below the mean. So then at 1 standard deviation, that's 1 minus 1 standard deviation. At minus 1 standard deviation, it is going to give you, take the mean, subtract the standard deviation 2.5, which is going to give you, so 63.6 minus 2.5 is going to give you 61.1, okay? Now at 2 standard deviations below the mean, that's going to be 61.1 minus 2.5, which is 58.6. Now, the question asks you that's going to be 1.5 standard deviation below the mean. If it's 1.5 standard deviation, it is going to be in between these two numbers because that's at -1, that is at -2. So let's go ahead and add them together. So I'm going to take 61.1 plus 58.6 and divide by 2. Which is going to give you a 59.85, and that is 1.5 standard deviation below the mean inches. And that is your answer. All right, you guys, I'm gonna have you guys go ahead and finish up for number 4. And that is basically it. When you guys are done with this, next thing I would like you guys to work on is take a look at the Quizlet, which is right here in the white. If you go ahead and click on that link, well, you can't click it, but I could. I want you guys to go ahead and take a look what this looks like. It's a multiple choice review of everything that we talked about in class starting from Unit 1. So go ahead and answer them. And then when you're done with that, you can go ahead and get started on the quiz for the 10 questions multiple choice. It's on quizzes, which is going to be on this link right here. And what I can do is I can go and post a link on MS Team as well. Once you guys start right here, you just go ahead and take a look at the live quiz and then just go ahead and get started. And that's basically it. I hope you guys have a wonderful day. And as always, stay safe and healthy. Take care.